Pleasant day, STEM learners. This is Sir Peter, your pre-calculus teacher. Have you watched the first video lesson in the ellipse? To continue, we will now talk about the standard equation of an ellipse center at 0, 0. At the end of this video lesson, you should be able to illustrate the standard equation of an ellipse center at the origin. Recall the definition of an ellipse in two-dimensional form. So it is a set of alcoplanar points such as the sum of the distances from the two fixed points is constant. So observe the highlighted word, the sum. Now, I also highlighted the word constant. Look at figure 1.21. Observe the distance from A to a point A with coordinates 4, 2, 4. And using a distance formula, the distance from the two foci, f sub 1 and f sub 2, using the distance formula, and since f sub 1 has a coordinate negative 3, 0, so we subtract the x values. We have 4 minus negative 3 squared plus 2.4 minus 0 squared. So we will get 7.4. So you can check using your calculators. And then the distance from point A to the other focus. In here we have 3, 0. So again, what you're going to do is to subtract 4 minus 3 squared plus 2.4 minus 0 squared. So you will get 2.6. So again, we use the distance formula to compute the distances from A f sub 1 and A f sub 2, meaning a point on the ellipse going to the two foci. So what you will obtain is a measurement which is 10. Next. Observe this one. What about if we have another point B? And since in the figure, the measurements are already given. From point B going to the first f sub 1, the first foci. So we have 3.8. So this is the measurement. And then from point B going to f sub 2, the measurement is already indicated. It is 6.2. Notice that we will still get a constant sum, which is 10. And remember, it's based from the definition of an ellipse, the word sum. Let's have another point. What if we have point C? So observe point C going to f sub 1. So we have C f sub 1, then C f sub 2. How did we obtain the measurements 5? Using the Pythagorean theorem, observe the legs of the right triangle formed here. So this is 3 units and this is 4 units. And remember the Pythagorean triple, 3, 4, and therefore the hypotenuse is 5 because 3 squared plus 4 squared is equal to 5 squared. So therefore, from point f sub 1 to C, that is 5 units. And from point f sub 2 to C, that is also 5 units. So C f sub 1 is 5 and C f sub 2 is 5. And still, we got a measure which is 10. Now, look at the vertices. So we have V sub 1 with coordinates negative 5, 0, and V sub 2 with coordinates 0, 5. And observe the length of the major axis. what is the length of the major axis? It is, notice that it is exactly equal to 10, which are all the constant sum. So meaning, the constant sum is the measure of the major axis. So the length of the major axis, which is 10, is this sum of the distances of any point on the ellipse going to the two foci of the ellipse. So that is what we refer to as the constant sum. So meaning, at any point P, look at point P. So this length and this length will always be equal to 10. So in a mathematical statement, from a focus to any point plus the other focus to any point, that will be equal to 2a. And what is 2a? Since the a distance is from center to vertices, so we have an a distance, and 2a will be the same distance here. So this is also a. So remember that 2a is the length of the major axis. So since we have a constant sum, in the formula of the standard equation of an ellipse, we also follow the pattern of a sum. So observe. So the standard equation of an ellipse, of a horizontal ellipse, is x squared over a squared plus y squared over b squared is equal to 1. While on a vertical ellipse, we have x squared over b squared plus y squared over a squared is equal to 1. Always remember that the length of the semi-major axis is greater than the length of the semi-minor axis. So in here, you would always observe that if the x part has a bigger denominator, then it is a horizontal ellipse. And if the the y part has the bigger denominator, which is a squared here, it will be a vertical ellipse. Say for example, if you have the values x squared over, let us write here, x squared over 36 plus y squared over 9 is equal to 1. What type of ellipse is this one? Is it a horizontal or a vertical? So again, do not forget this rule. A is greater than B. So since this is a squared, A will be positive negative 6. Then this is B squared, so that is positive negative 3. So notice that the x part is bigger, so therefore this is a horizontal ellipse. Consequently, if you have this example, x squared over 9 plus y squared over 36 is equal to 1. It takes the form of the vertical ellipse. Why? Because the A here is the bigger one. So this is now our major axis, which is A. And our B is still 3. So if the x part has a bigger denominator, it is a horizontal ellipse. While in here, if the y part has the bigger denominator, then it is a vertical ellipse. Do not forget that distances A, B, and C can also be computed, just like the Pythagorean theorem, but it's quite different because the Pythagorean theorem is C is equal to the square root of A squared plus B squared. So it's different because in here, C is the hypotenuse in a right triangle. So it is the longest distance. But in an ellipse, the longest distance is A. So A will be equal to the square root of b squared plus c squared. Consequently, when you want to find the b distance, which are the semi-major axis, and then the c distance from the center going to the focus, you will use these formulas. So reviewing again, 2a is the major axis, 2b is the minor axis, 2c is from focus to focus. A is what we call our semi-major axis. B is our semi-minor axis, which is center to co-vertex. And C is our distance from center to focus. So do not also get confused, because in the formula, what is reflected is a squared and b squared. So whatever the value of a and b, you should square them on the standard equation. So observe this one. For the ellipse with foci on the x-axis, meaning they are on the x-axis percent. So if this is the coordinate plane, so it is the x-axis in which your foci are located. So again, the formula is C is equal to the square root of a squared minus b squared for these distances. And remember that a is the longest distance and it's always greater than b, which is the semi-minor axis. For the vertices, here are the formula: positive negative a0, positive negative c0. Comparing it to a vertical ellipse, it is 0, positive negative a, 0, positive negative c. For the major axis, the equation is y is equal to 0, or it is the x-axis itself. For the vertical ellipse, we have x is equal to 0, or it is the y-axis itself. The minor axes are also contrast. So observe the difference. For the equation of the directrices, although this is not computed anymore, it is x is equal to positive negative a squared over c. So simply square the a distance divided by c. And since we have two directrices, so we have a positive and a negative, both on the left and on the right of the horizontal ellipse. Same is true with the vertical ellipse. We have a positive, negative, but this time they are located, the directrices are located above and below the vertical ellipse. For the latera recta, the length is usually important to measure. The length is 2b squared over a. And we will form 4 endpoints of the latus rectum, but we will not be computing them anymore. Now let's have an example. Give the coordinates of the foci, the vertices, and the co-vertices with the equation x squared over 25 plus y squared over 9 is equal to 1. So first is to define the three distances. For the a distance, we have positive, negative 5. For the b distance, obviously b should be 9 because a is always greater than b. So it's positive, negative 3. So do not forget that to get c, we use this formula. The square root of a squared minus b squared. So c now is 25 minus 9. So c is positive, negative 4. Now, determine what type of ellipse do we have. Correct. The answer is horizontal ellipse. Reason? It is because the x part is bigger than the y part. So it will look like, when we draw the ellipse, it would look like a horizontal ellipse. Now, to determine the vertices and the foci, remember that they are located on the x-axis because the foci and the vertices are collinear. So therefore, since they are located on the x-axis, so for f sub 1, we follow the formula positive, negative, c. So we first get the negative part, so -4, 0. Then for f sub 2, we have 4, 0. For v sub 1, so you get the value of a, so that is -5, 0. And your other vertex is 5, 0. So that is how easy it is. And remember, the co-vertices are non-collinear with the foci. So they will be located on the y-axis. So when we write one of the co-vertices w sub 1, it will be located at the y-axis. So it's 0, -3. And for w sub 2, we have 0, 3. Okay, so we already have answered that part. Let us continue. So this is how the graph would look like. So notice the coordinates. Let me draw the coordinates here of the vertices. So it's correct. It's -5, 0. And this is 5, 0. So where is the focus located? It's located on -4 here and here. Okay, and the co-vertices are located here. So these are important points to form. The latus rectum is very important also, so that you could connect the endpoints of the latus rectum. These are points which you could be used to connect the curve. Okay, but we will not be talking about them anymore because the skill that you need to learn is how to give the foci, the vertices, and the co-vertices. Next question. Give the coordinates of the foci, vertices, and co-vertices of the equation x squared over 25 plus y squared over 169 is equal to 1. So again, the problem becomes different because our A should be the longest distance. So we will get 169 as our A. So to get A, sorry, let's use a white marker. So A is equal to the square root of 169. This is A squared in the formula. So you get the square root. It's positive, -13. B is positive, -5. So how did I get that? Because this is B squared. And to find C, we need to use the formula. The square root of A squared minus B squared. So that would be 169 minus 25, which is equal to the square root of 144. So C now is positive, -12. Any question? Now let us determine now the type of ellipse. So I'll put it on top. What type of ellipse do we have? Very good. We have a vertical ellipse. Can you reason out why is it a vertical ellipse? So it is considered a vertical ellipse because the y part is now bigger than the x part. So since it is a vertical ellipse, the foci and the vertices are located on the y-axis. So to form f sub 1 and f sub 2, the coordinates must be at 0. So you get c value, negative 12. Get the negative first, then 0, 12. For the vertices, v sub 1 and v sub 2, again, they are collinear with each other, so they will share the same format. So we will have 0, negative 13. Can you follow? And 0, 13. For the endpoints of the co-vertices, the endpoints of the minor axis, co-vertices, they will be located on the x-axis. So that will be negative 5, 0. So get first the negative. Then the positive part is 5, 0. So I hope you understand. So this is now a sample graph. So let us locate all those points. The foci are 0, 12. So yeah, maybe they are located somewhere 11, 12. Oh, I use a different color. Here. And then 11, 12. Here. So these are the foci of the ellipse. The vertices are located here. While the co-vertices are at negative 5, 0 and 0, 5. So I hope you got it easy on how to get the foci, the vertices, and the co-vertices. There are also other important parts in the ellipse, but since we only have limited time, I cannot discuss with you everything about the ellipse. So always remember that c is equal to the square root of a squared minus b squared, and that a is always greater than b. Consequently, it will also be greater than c distance. So in the standard equation of an ellipse center at 0, 0, if the x part has a bigger denominator, the ellipse will be horizontal. And if the y part has a bigger denominator, the ellipse is vertical. For the distances, we have the major axis is 2a, the minor axis is 2b. Do not forget that. A focus to focus is 2c, and the c distance can be computed like that. The latus rectus also has a measure which is 2b squared over a, so you could measure it. And the eccentricity of an ellipse is always less than 1. So unlike with the eccentricity of a parabola, the parabola has an eccentricity exactly equal to 1. But for an ellipse, it is less than 1. The eccentricity of a circle is 0. That's why a circle is considered an ellipse, because it is 0 is less than 1. So therefore, the eccentricities that we could compute might be 0 point something. So in short, the eccentricity is c divided by a. Okay, so of course, whatever the value of c, for example, in our last example, that is 12, and then our a distance is 13. So the eccentricity of the problem that we have presented a while ago is 12 over 13. So that is less than 1. So these are again characteristics of an ellipse in terms of their constant ratio, the eccentricity. Here are the references used in this presentation. So I hope you learned something from our discussion. So we are not still done with our week number 3 because we will still be talking about the standard equation of an ellipse. This time, the location of the center is located anywhere on the Cartesian plane. So it's not located anymore on the origin, but it is located anywhere on the Cartesian plane. And that is center at HK. So again, this is Sir Peter, your pre-calculus teacher.